Before attempting to translate problems to equations, we need to be able to translate certain phrases to algebraic expressions. To do this, we need to recognize certain terms represent mathematical operations. And I have here a table of those terms with the indicated mathematical operation. If you see under addition, we have added to, sum of, plus, more than, increased by. Under subtraction, if you see the terms subtracted from, difference of, minus, less than, decreased by, the implied mathematical operation is subtraction. For multiplication, multiplied by, product of, times, twice of. For division, we have divided by, quotient, which is the result of a division problem, divided into, ratio of, and per. All of these indicate division. So let's take a look at some examples of algebraic expressions and translate them into an algebraic representation. This first one here says 4 more than Jean's height. So we can pick a variable to represent the unknown, Jean's height, and it says 4 more than that, which implies an addition of 4. The next one is 18 more than a number. We don't know what the number is. We are going to pick a variable to represent that, and it's telling us 18 more than that, which implies an addition just like the one above. The next one is a day's pay divided by 8. Day's pay is what the unknown is, so we can pick some variable to represent the unknown, divided by 8. Now division and subtraction, order is important, and the order that we use is the order that the numbers come in. Since pay was first and 8 was second, this is how we would translate that. Had the problem been 8 divided by a day's pay, we would have had the 8 in front divided by p. So subtraction and division are problems that we do have to pay attention to the order, because they do not hold for commutative property. And we'll get into that later in an upcoming video. Some other examples of algebraic expressions that we need to translate. Half of some number. So we're going to take some number, which is unknown, our variable, and we are going to take half of that. The of means multiplication. Here's our 1/2, so 1/2 times some number, our variable that we have here. So this could be written this way, or when you're taking half of something, it means you're dividing it by 2. So both of these would be equivalent expressions for the phrase that we have here. 3 more than twice a number. So a number is unknown. We're taking twice of that. So twice of our unknown number. And then if we look, it says 3 more than that. So we will add 3 to that. So 3 more than twice, which is 2 times the number. The 2 adjacent to the variable is an implied multiplication. 6 less than the product of 2 numbers. So product is an implication of multiplication of 2 numbers. Well, we don't know what those numbers are. We can call them x and y, but it says product of those, so it means they're being multiplied together. So there's the product of 2 numbers, and it's asking us to take 6 less than this. So here's the product, and to take 6 less than that, we will put the subtract 6 at the end. This last example, 54% of the student body. We don't know student body. There's our variable. Of implies multiplication, and we're taking 54% of it. So one option would be 54% of, which means times the student body, using x to represent the student body, would be an acceptable translation, or the decimal equivalency of 54% is 0.54, moving the decimal 2 places to the left, and then of our multiplication times our unknown, which in this case, student body.